Hello friends, continuing with the topic of transistor and its applications. Today we come to another part of it, feedback amplifier. Previously we have studied transistor as an amplifier. Now we study about feedback amplifier. Before we go for understanding of feedback amplifier, we are to understand about the term feedback. What is feedback? The process by virtue of which a portion of output is fed back to input of the amplifier is known as feedback. I repeat, the process by virtue of which a portion of output is fed back to input of the amplifier is known as feedback. Now, feedback amplifier. Feedback amplifier is an amplifier which is applied with feedback. Now here you can see it's amplifier and this is feedback network through which we apply feedback. So a portion of the output is taken and it is applied to the input here. Simply you can say feedback amplifier is equal to amplifier plus feedback. This is mathematically we can say the two together, amplifier plus feedback becomes feedback amplifier, or amplifier applied with feedback is known as feedback amplifier. Now type of feedback. Number one, negative feedback. Number two, positive feedback. Two types of feedback we apply normally. First is negative feedback, the second is positive feedback. We take up one by one. First, negative feedback. Let us define. When portion of output fed back to input is out of phase with the input, the kind of feedback is said to be negative feedback. I repeat, when a portion of output fed back to input is out of phase with the input, the kind of feedback is said to be negative feedback. Now look at this diagram. This is the input signal and this is the feedback portion, so which is out of phase with the input. So we say it is a negative feedback. Now advantages of negative feedback. First, stability increases. Second, bandwidth increases. Third, noise reduces. Fourth, distortion reduces. I repeat, advantages of negative feedback. First, stability increases. Second, bandwidth increases. Third, noise reduces. Fourth, distortion reduces. Now disadvantages of negative feedback. The bigger disadvantage of negative feedback is the gain reduces. Gain of the amplifier reduces when we apply negative feedback. For so many advantages, gain is sacrificed and negative feedback is employed in amplifiers. So we can sacrifice gain at the cost of advantages. So there are so many advantages as we have mentioned above. Stability increases, bandwidth increases, noise reduces, distortion reduces. So for these advantages we can sacrifice gain and we apply negative feedback. Now expression for gain with negative feedback. Consider an amplifier with amplification factor AV. Let VO be the output voltage and Vin be the input voltage applied to the amplifier. Then amplification factor AV is equal to V output over V input, or we can say gain AV is equal to V output over V input. Let alpha VO be the fraction of the output fed back to input out of phase with the input as shown in diagram. Now input voltage after feedback. After the application of negative feedback, V input reduces and becomes, say, V input dash is equal to V input minus alpha VO. Why minus alpha VO? Because alpha VO is out of phase with the V in. Now gain with feedback. Since gain AV is equal to V output over V input and V output is equal to AV into V input. Therefore, with negative feedback, we have V output is equal to AV into V input dash. Therefore, from here we can have V output. Now substituting the value of V input dash, we have V output is equal to AV into V input minus alpha VO. From here we open the bracket and we get VO equal to AV into V input minus AV into alpha VO. Now shifting AV alpha VO to the left hand side, we get V output plus AV alpha VO is equal to AV into V input. Now taking out VO common, we get VO into 1 plus alpha AV is equal to AV into V input. From above equation, we have V output over V input is equal to AV over 1 plus alpha AV and is the gain with feedback. If we denote gain with feedback as AF, then we have AF is equal to AV over 1 plus alpha AV. Let us look at the next slide. This is coming up. Now the expression AF is equal to AV over 1 plus alpha AV. If gain with feedback is denoted by AF, then AF would be equal to AV over 1 plus alpha AV and is less than 1. Why less than 1? Because denominator is more than 1. So therefore AF would be less than 1. That is of the order of 0.9, 0.8, so on. Thus gain reduces during negative feedback. So mathematically we can explain here that the gain with feedback is less than gain without feedback. That is AF is less than AV. Now we come to second type of feedback, positive feedback. So let us define first positive feedback. When a portion of output fed back to input is in phase with the input, the kind of feedback is said to be positive feedback. I repeat, when portion of output fed back to input is in phase with the input, the kind of feedback is said to be positive feedback. Now second, disadvantages of positive feedback: stability reduces, bandwidth decreases, noise increases, distortion increases. The advantages in negative feedback becomes disadvantages in positive feedback. The third advantage is gain increases. With increase in gain, stability reduces, bandwidth decreases, noise increases, distortion increases. So either you take the advantage or you take the gain. Choice is yours. Now expression for gain with positive feedback. Consider an amplifier with amplification factor AV. Let VO be the output voltage and Vin be the input voltage applied to the amplifier. Then amplification factor or gain AV is equal to V output over V input. Is the same as we have written for negative feedback. Let alpha VO be the fraction of the output voltage fed back to the input in phase with the input as shown in diagram. This is the input signal. This is the fraction fed back which is in phase with the input. So this constitutes a positive feedback. Now input voltage after positive feedback. When we apply positive feedback, then V input increases and becomes, say, V input dash is equal to V in plus alpha VO. Why plus? Because alpha VO is in phase with the V input. Now gain with positive feedback. Since gain AV is equal to V output over V input and VO is equal to AV into V input, therefore, after application of positive feedback, we have VO is equal to AV into V input dash. Substituting the value of V input dash, we get VO is equal to AV into V input plus alpha VO. Now opening the bracket, we get VO equal to AV into V input plus AV into alpha VO. Now shifting AV alpha VO to the left hand side, we get VO minus AV alpha VO is equal to AV into V input. Now taking VO common in left hand side, we get VO into 1 minus alpha AV is equal to AV into V input. Now from above equation, we have V output over V input is equal to AV over 1 minus alpha AV and is the gain with feedback. Now gain with feedback is more than 1 because denominator is less than 1. We will look into it in the next slide. Now the expression AF is equal to AV over 1 minus alpha AV. If gain with feedback is denoted by AF, then AF would be equal to AV over 1 minus alpha AV and is more than 1 because denominator is less than 1. Something is subtracted from 1, so it becomes less than 1. Thus we see gain increases during positive feedback. Thank you so much. Next time we'll take up next part of it, the oscillator. Till then, goodbye and good luck to you.